In the last class we studied about this formation of different types of compounds, right? So today we will be learning about the property of covalent compounds. Now, what is covalent compounds? So, see, the compounds containing covalent bonds are called as covalent compounds. So, if we will say in a very simple language, it means it involves the sharing of electrons to form electron pairs between the atoms. It shares what? It shares your electron to form electron pairs between the two atoms or between the three atoms, but between the two atoms mostly. Okay. Now, what is over here that covalent compound have low melting and low boiling point. Why? Because due to its low intermolecular forces of attraction between the molecules, the two atoms, the attraction between the two atoms is what? Is very small. The interaction between two atoms is very small. That's why the covalent compound is having low boiling point as well as low melting point. Why? Because the smaller intermolecular forces between the two atoms. The two atoms is forcing a smaller intermolecular forces. Now, this was the first point. What is the second point? That it is a poor conductor of electricity. If a boiling and melting point is low, so obviously it will be a poor conductor of electricity. And now this is why, this is because the electrons are shared between atoms and no charged particles are formed. See here, your electrons are shared between the atoms. Here also your electrons are shared between the atoms. That's why it's what? The poor conductor of electricity. It is the poor conductor of electricity. Third, that they are generally volatile in nature. Okay, so what was the first one? First one was they'll have low melting point and low boiling point. Why? Because the intermolecular forces between the two atoms is very low. That's why they'll have low melting point as well as low boiling point. What was the second point? Second was that very bad conductor of electricity, poor conductor of electricity, bad conductor of electricity. Why? Because the two atoms share electrons, like they share electrons from each other. That's why they'll have a bad conductor of electricity. What is the third point? Third point is that they are volatile in nature. Volatile in nature. Okay. So this is the property of your covalent compound, and this is the definition that it involves the sharing of electron. Why? To form electron pair between the atoms. Hmm? Now we will see some example. This part you got it now, that it's having low melting, low boiling because of small interaction between atoms. This is a poor conductor. Why? Because the electrons are shared between atoms and no charged particles are formed. That's why poor conductor, and the nature is volatile. This 3 point is clear, Shafia, Rudra?
Yes, ma'am.
Okay. Now we will see some examples. So if we will see example first, it's saying carbon a group 14 element in the periodic classification is known to form compounds. Now we will see here your carbon is first combining with your chlorine. This is the solution of this, and second it will combine with your oxygen. This is the oxygen one. Now if we will see that carbon is having how much in the outermost shell? It's having six. No, so Kl, so 2 and 4. And what about your chlorine? Yes, chlorine is having how much atomic number? It's 17. So it will be Klm287. So it needs 4 more electron to fill its octet. And here this chlorine needs only 1 more electron to fill its octet. So how we will draw this? We will draw like carbon is having how much in the outermost? Yours 4. And what about your chlorine? And what about your chlorine is having how much? 7, right? So chlorine is 1, 2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. No, no, I'm so sorry. Like this, we will not make. We will make like this. Hmm. Because chlorine needs only one now. That's why we have to make over here only one. So 1, 2, 3, 4, 5, 6, 7, and here 1, 2, 3, 4, 5. Here also 1. And it needs how much? 4. So see, now this will combine with all your 4. This is your 4 electrons. So carbon part is done. It's already having 4 and it need 4. So this is your 4 electron. This is 1, 2, 3 and your 4. Here also I'll make one chlorine. I forgot to make one, two, three, four, five, six, seven. Okay, and how much chlorine? Chlorine needs only one. So chlorine will combine like this, and this. Okay, so it will be like carbon and bonded with your chlorine, and carbon bonded with 4 chlorine. So it will be what? CCl4. Now, what is the name of this CCl4? Anybody? Safia, what is the name of this CCl4? See, the CCl4 name is carbon tetrachloride. Now, why C for carbon, Cl for chloride, but it's having 4 over here, so it will be tetra. So it's what? This is your carbon tetrachloride. Okay, next. Next is what? Next, your carbon will combine with oxygen. So now you guys make this diagram that carbon is combining with oxygen and send me in WhatsApp.
Dot structure.
What?
The dot structure.
Your voice is not audible.
Do we have to make the dot structure?
Mm-hmm. Dot structure of carbon and oxygen. Carbon and oxygen. This is for your chlorine and oxygen, right? Send me, I'll give you 2 minutes time, okay? Come on. Done? Rudra, do you know how to make this? Can you please tell me the atomic number of these two, carbon and oxygen? Okay, so let me make. Carbon is having how much? 6. So it will be Kl 2 and 4. Oxygen is having how much? Oxygen atomic number is how much?
Eight.
Yeah?
Eight.
It's 8. So Kl 2 and K will be 6. So now carbon needs how much? 4 more. And oxygen needs how much? 2 more. Now we will see the covalent compound. Carbon 4 in its outermost. Oxygen is having how much in the outermost? 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So needs we will carbon is 4, right? So I guess we will not make like this. We will make like this. Carbon 2 and 2. Why? Because oxygen will have 2 now. So carbon 2 over here and 2 over here. Okay. So now carbon wants 2 more. So it will combine like this and it will combine like this. And your this oxygen needs 2 more. So it will combine like this, combine like this. So it will be what? Your OCO means CO2. This is your carbon dioxide. Safia, clear?
Yes,
See.
ma'am. I've sent that on the WhatsApp group.
Acha, you have already said. Okay, let me check. Good. Why? Because this needs two, this needs two, and here also it needs two, 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 two. So two, two, everything is fulfilled. So this is your covalent compound between the carbon and chlorine, and the second one between carbon and oxygen. Now, what is the next? Next is your difference between your covalent compound and your ionic compound. So this is your ionic, this is your covalent. First, we will see the nature of these two. So, ionic compound nature is what? That their constituent particles are ions. Why? Because ionic, so obviously their the particles will be ions, and they are hard solid consisting of ions. Okay, first. Now in the covalent, there are like this is what their constituent particles are molecules, and these are gases, liquids, and soft solids. But this is what your hard solid, and this is your soft solid. Now, what is the reason behind this? Ki why this is hard and why this is soft? So, the reason is these have strong intermolecular forces of attraction between their ions. Ions are having what? Strong intermolecular forces. That's why these are hard solids. And what about the reason of this covalent? That they are having weak intermolecular forces of attraction between their molecules. That's why these are soft solids. Okay. Now, what is the next one? Your boiling point. These are non-volatile with high and with low boiling point, and we already know about covalent compound that they are having low boiling point. Why? Because the intermolecular forces of them between, like the intermolecular forces are very weak between them. That's why the boiling and melting point is very low. Here, this is non-conductor of electricity. This is your good conductor of electricity. Solubility. These are soluble in water, but insoluble here, and this is insoluble in water. Why? Because as organic solvents are non-polar, so means this will dissolve in the covalent compound. So that's why this is insoluble in water, and here this is normally soluble in water. So these are the four main points. First, about your nature, they are hard, they are soft. Second, boiling point, this boiling point is very low, this is very high. Electrical conductivity, poor conductor of electricity, good conductor of electricity. This is solubility, this is soluble in water, and this is insoluble in water. Okay, so this is the difference between the covalent and your ionic compounds. Now, next, what we will, this is big chapter now. Next, we will talk about the allotropes. Now, you tell me, what is allotrop? Any idea? What is this? Think and tell. What is allotropes? No? Okay, so here, your allotropes is what? Allotropy is what? It is the property by virtue of which an element exists in a more, like your diamond, your graphite, or any element which is existing in more than one form, and each form has different physical property but identical chemical properties. Now you got it. That, see, your, where, like, which an element exists in, like, this is, let's say this is my A element, this is existing in three forms: your A1 form, A2 form, and A3 form. But these all three are having your different physical property, different physical property, but they will have what? Same chemical property. This is the definition of your allotropes. That there's a one element which is like, which is having three or more than like two forms. Here I'm taking three forms of A, and which will have your different physical property, and it will have your same chemical property. So this is the definition of allotrope. An element is having two or three forms which will have
Now,
different physical. Huh?
so this can be for any element.
Yeah. What?
This can be for any element.
Not for any element, but there are some elements in allotropes, because we are studying allotropes of carbon now. So it will be related to only carbon, like your diamond, your graphite, your fullerenes. See here, see, this is also written: diamond, graphite, fullerenes. These three will have what? Will have more than one form and the same chemical but different physical. Now we will see the example. This is your crystalline form. What is your this is your microcrystalline form or amorphous. Example is coal, lambac, and your chalk. So see, diamond. Diamond general property is what? That this is colorless, transparent substance. We all know the structure of diamond, है ना? Highly refractive index, high and extremely hard. Diamond is very hard, and it is not a good conductor of electricity, but it has high thermal conductivity and high melting point. So this is general your some properties of your diamond. So this is the structure of your diamond. Diamond is like this, na? Something like, I don't know, like maybe different shapes. Hmm. I can't say like this. In different shapes, a diamond is present. So it is a giant molecule of carbon atom. This is what? Carbon, 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 carbon. Everywhere is your carbon atom. Why? Because we are studying allotropes of carbon. So diamond is made up of your carbon atoms, in which each carbon atom is bonded to four other carbon atoms. Like your each carbon atom is bonded to four other carbon atoms. Again, your this carbon atom is bonded to other four. This is bonded to other four. This is bonded to other four. Okay, like this. So where each carbon atom is bonded to four other carbon atoms, forming a 3D network. It will form what? See, this looks like a 3D, na? So this is forming a 3D network by carbon combining with four other carbon atoms. And this is what? This is very hard, and a lot of energy is required to break. If we want to break this bond of diamond, this strong covalent bond of diamond, so what we need? We need a lot of energy to break this. Why? Because its melting point is very high. That's why we need a very large amount of energy to break this diamond. So if we will see here, okay, this is your graphite. Okay, so this is what? This is about your diamond. So this is existing in more than one form, है ना? And it's having your same physical, different, sorry, different chemical. Oh my God, same chemical but different physical properties. This is your yeah, diamond. So what is the important point over here? That diamond can be prepared artificially by subjecting pure carbon to high pressure. See, if we will combine the carbon now in a very high pressure, then it will become a Diamond. Okay, so diamond is like combining the carbon atoms to four other, making it making it making like a 3D structure. So it will be a diamond. Second is your graphite. Graphite is what? Pencil. And a pencil is what? Your graphite. Graphite looks like this, the structure of graphite. So it's grayish black, lighter than diamond, smoothie and slippery to touch. If you will touch the pencil, so it's what? It's like a smooth, no? Smooth and some slippery thing is there, and it's a good conductor of electricity, but a bad conductor of heat. Now this is the structure that graphite is. Now this is also a layer of carbon atom, sheet of carbon, and each carbon atom is joined with three other carbon. There in the diamond, the each carbon atom was joining with the four other carbons, na? And in the graphite it will join with three other carbons. So it will form a hexagonal ring, means your six. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Okay. It will make what? Hexagonal ring. So, however, the fourth electron of each carbon atom is free, which makes it good conductor of electricity. Here, your carbon will combine with three. And what about your this one? What about your this one? So, this is busy in making this whole thing a good conductor of electricity. That's why this is what the graphite is, a good conductor of electricity, and your diamond is a bad conductor of electricity, because in diamond all four carbon atoms are combining to make a diamond, and here in graphite there are only three atoms are combining to make a diamond, and one each electron is busy in making it a good conductor of electricity. Okay, now you got it why diamond is bad and why this graphite is good conductor of electricity, Safia.
Yes, ma'am.
Okay, any doubt you can ask, huh? So the various layers, so this is the structure of your graphite. Next, we will see the structure of your fullerences. After this, we will learn about the versatile nature of carbon and then hydrocarbon. Okay, Safia, this chapter is over in your school or it's going on?
It's going on.
Okay, till which topic it's done?
We've done it till alkanes and alkynes.
Oh,
Uh,
alkenes
yeah.
and oh, okay. And what about roads? Chapter done in school?
Ma'am, actually, my teacher, she wasn't teaching according to the book. Like, she started some topics first, and we haven't done these topics yet.
Oh,
We
these?
we uh,
Oh,
we didn't do this, and we actually started with alkanes, alkenes, and alkynes, and then we did functional groups also.
okay. This you did, functional group. But we are going topic wise now. This is about your allotropes, graphite, and this is your fullerences. So these are what recently discovered allotropic forms. Earlier was only two, your graphite and your diamond. So which were prepared for the first time by this is the scientist H.W. Proto, Smalley, and Robert Kirk by the action of laser beam on the vapor of graphite. What they did? They put laser beam on the vapor of graphite. If we'll heat a graphite, so it will form a vapor, right? So they put what? They put the action of the laser beam on the vapor of the graphite. So the first known fullerene was C60, which contains 60 carbons arranged in the shape of your like this football, and with smaller proportion of C70 and traces of compounds containing up to ethna carbon atoms. Means fullerene is having how much carbon atom? Your 60 carbon atom, and the name of this is bulk Minster fullerenes due to their resemblance in structure, and the structure of this is your like a football, and diamond structure was like a 3D, and here your this graphite structure is like your hexagonal. So now you guys tell me that diamond can combine with how many carbon atom to form a 3D structure? It will come. It will combine with how much carbon? Two carbon, three carbon, four, five, six. How much? Sophia,
Yes, ma'am.
diamond will combine with how many carbons?
Ma'am, it combines with four carbons.
Four carbons, and it's a good conductor of electricity or bad?
It's a bad conductor.
Why?
Because there are no free electrons.
Hmm. Yeah. And graphite is having three carbons, and one is your free electron. That's why it's a good conductor of electricity. Okay. So now this is the next topic, your versatile nature of carbon. So this will start in the next class. Okay, versatile nature of carbon. And in December, this is your November, right? November is going on. In December, there will be whole, like each there will be test. Whole month test will be there. Different questions, your practice paper, NCRT questions. Because in Feb you guys will are having exam now from Feb 17 maybe.
Yeah.
So it's only two months. Means approx 2 months, 2 3 months. So in December, if we will go with different types of question now, then it will be easy for you guys to, challenging question there will be. So it will be easy for you to challenge the question of CBSE. Now, versatile nature. What is versatile nature of carbon? So the estimated number of carbon compounds known today is about 3 million. Oh my God, carbon compound is how much? Like till today is 3 million. It's a lot. But now the question is, which property or properties of carbon are responsible for the formation of such a large number of carbon compounds? So these are the properties: your catenation, your tetravalency, tendency to form multiple bonds. So these are your properties which are responsible in forming a large number of the carbon compounds. So first we will talk about the catenation. What is the catenation? Yeah, what is catenation? The property of self-linking. Now you tell me, you explain me this paragraph, that what is catenation? Anybody? Safia Rajja. What is catenation?
It's the property of carbon to form bonds
Mm-hmm.
with other carbon atoms,
Hmm.
and it can form long chains.
Hmm. Yeah. The property of self-linking of elements, mainly carbon atom, to form a straight or branched chain and rings of different sizes of catenation. Now, means C and C, if C will combine with another C, so it will what? It will become very strong bond between them. है ना? So this is your catenation, your straight or branched chain carbon-carbon strong bonds will happen. This is your tetravalency. Tetra means four, we already know. So its atomic number is 6 and electronic configuration is carbon. Huh? Carbon atomic number is 6 and electronic configuration is 2 and 4. So it's having 4 in the outermost shell. So it's need 4 more. The valency will be 4 over here. That is, it is capable of bonding and pairing with 4 other carbon atoms. है ना? It is capable of bonding with other 4 carbon atoms. So like hydrogen, it will combine with hydrogen, it will combine with your halogen, chlorine, bromine, etc. So this is what your catenation means, like carbon is combining with like this here catenation, carbon is combining with carbon only to making a strong bond. Tetravalency of carbon means carbon is combining with any other atoms to form to complete its octet. Huh? Because in this there's only 4 octets, so it needs 4 more to complete its octet. Now, what is tendency to form multiple bonds? Due to its small size, carbon has a strong tendency to form a multiple bond, double, triple bonds by sharing one electron pair with own atoms, with the atoms like oxygen, nitrogen, sulfur. Now, what carbon will do? Carbon will combine with oxygen. Just like we see now, the carbons combine with oxygen means there was 2 bonds here. There's a double bond now. Where's it? This one. Here's your double bond. If carbon is combining with oxygen, this is your double bond. So here your carbon will combine with these to form double, triple, or any kind of a bond. Okay, so this was your versatile nature of carbon. First, catenation, carbon-carbon strong bonding, tetravalency means 3 carbon, so it needs like electronic is this, so it needs other atom to complete its octet, and tendency of multiple bonding. Multiple bonding means one bond, not one, two, or three. Bonding is your multiple bonding, just like we saw na carbon and oxygen is forming a multiple bond like this. So this is your double or triple bonding. So this were the 3 properties of your carbon atom. So in the next class we will talk about the organic compounds and your hydrocarbons, saturated, unsaturated, alkene, alkyne. Okay. Assignments submitted. A1 of this chapter. Sophia, assignment done.
Yes, ma'am, I submitted it.
Okay. Okay. Thank you. Bye bye.
Thank you, ma'am.